Okay, so last week we get started for Python for data science and Python programming essentials. So this is level 1 Python. Okay, we do brief Python. That's an overview of Python language. Now we go into the Python for data science. So today we are going to continue for chapter 3, and this chapter 3 may be short, and then we'll go to chapter 5. Chapter 5 will be the list, string, and file processing. Okay, we may go into the chapter 5. So chapter 3 is data type. Okay, and we actually finished it already. And then we may soon go into the chapter 5 for string, list, and files. But in between chapter 3 and chapter 5, we may also start data science using Excel files, okay, before we go into the file processing part. Okay, so we will get started here. Okay, so now let's get started for numbers. We are going to review it since this chapter we already finished it. So counting with numbers. So this basically is dealing with data. Okay, so you have different kind of data type. You handle the math library. I think we already covered some of these. And then write program for the data. Okay, so these are what it is. So data type, you have number type, string type, Boolean type. These are primitive data type. You have combo type of the list, tuple, set, array, bytes or array. Okay. This one. Okay, and then there's a dictionary. Dictionary is combining two lists or two tuples will become a list, a dictionary. Okay, so these are different data types we talked about so far. We already covered it. Okay, so you have a tuple. Okay, you have a tuple. You have different data types. C language, there are many different data types. And there is a language called C Python. You can also install C Python. Okay. C Python. C Python is Python running on C language. That would be faster. So if you install C Python, it will be faster. So we don't install it for you, but if you want to install the C Python, you go to the internet and then do C Python installation. And then you will do another one. Let's don't have this installation, just C Python. So there's a C Python source code, whatever. Okay, so there are C Python related things you can study. Okay, whatever. We don't want to waste a lot of time. Those parts you have to study by yourself. And then you have the numbers. So the numbers, okay, and then boarding point, okay, literal, okay, these are okay. So this different data type is okay. And then the operators, plus, minus, dollar sign, floating point division, integer division, these two pay more attention. Exponential, 2 raised to the power 2, okay. This one special. And then reminder, okay. Remainder. The rounding, we talked about it already, so let me check another things. Okay, this rounding part is okay. I think everyone okay for this one. The math library is a library for the ABS, for the absolute value maximum minimum. Okay, there are a lot of functions. Okay, let's just solve this one for this one. Let's try to solve this, the root of the quadratic equations. Okay. So we will talk about using math representation for functions and also solve the equations. Okay. First one, let's represent a function. Okay, so to represent a function, we may have two ways to represent function. One is called symbolic representation. Hi, Liana, how are you? So we have two ways to represent a function. One is called symbolic representation. The other way to do it is called numerical representation. Okay, numerical. So one by number, one by symbol. Okay, one by one number, one by symbol. So let's review the quadratic function. So quadratic function, you do have a function that's a hyperbola, parabola. Parabola, you have x, you have your y equals f of x equals ax squared plus bx plus c, right? You have this. And your chart is like this. Okay. Everyone okay with this quadratic function or no? Anyone have not studied this? Algebra 2, right?
Yeah.
Belinda, are you okay?
Yeah, I learned this already.
How about Liana, are you okay?
Yeah.
Okay. I'll make sure everyone learn this. So let me ask a question, right? Right now, let me have Sherry. Sherry, let me ask you a question. So what do you know about A? If you tell me what A will tell you. If you know about number A, what does A tell you?
Like, oh, if it's positive or negative, so like maybe like up and down.
What?
What's it called? Like whether if it's like positive.
Use your language. I will understand it. No problem. You just try to use your language.
Okay. Like if A is greater than like 0, then
So A greater than 0, what happened?
like the open like is gonna go like up, and then
This is called concave upward.
yeah, concave up, and then
Concave upward. Okay, concave upward. This is called concave downwards. Okay?
Yeah.
They have different names. Sometimes it's called concave and also another name. I forget it. Let me check, okay? It's called concave function. Let me check, okay? You concave upward and okay, here. Let me post it. Post it in the group, okay? We are reviewing math right now, okay? Because we are Python for data science, so we need to learn some math as well, okay? And that's also the purpose of studying the data science. You need to know about math anyway. So let's go back to here. Actually, you have a function. You have function, and then A determine is concave downward or concave upward. Concave upward also called convex function. Concave downward also called concave function. Is that okay? So A negative, you get this. A positive, you go this way. Okay. This one I asked Sherry because this is related to calculus. Calculus second derivative, you get that. Okay, it's good. Now, second question, this one. So this one, you do have a y equals ax squared plus bx plus c. It is equal to ax plus. This one is actually b over 2 actually 2a, let me see, squared okay, and then here you should have a so it's this one is, let me see, it's actually a, let me see, I'm sorry, let me redo it away. I actually forget the equation. Let me do it one more time, okay? So this one would be equal to ax squared plus b over ax plus c, okay, over a, okay, and this one should be ax squared plus b over ax plus this one is actually b over 2a. Let me see. Okay, this one square. Okay. And then plus c over a minus b over 2a. This is a minus, okay, square. This one you have 2 but cancel 1, so this one is a 4, right? It's a 4. Something like that, okay? And then it should be ax plus b over 2a squared plus minus, okay, minus b squared minus 4ac divided by 4a. Okay, this one you should have a square and then you put a over here, okay? Something like that. So this one equal to ax plus b over 2a square minus, okay, here you should have a square root b squared minus 4ac divided by this one is actually this one actually is square, it actually is square is 4a squared, something like that, okay? OAC, okay. Okay, whatever. This one actually is the equation, okay? This one is the minimum. So anyway, this one you can derive it, okay? Anyway, we have this. So what is this line? Line of symmetry. This one for Belinda, what is this line?
Wait, that's like the line of symmetry, and you get it from it's the x coordinate of the vertex.
Yeah, so this is point. And then what would be the x?
What would be the x? Negative b over 2a.
Yes, because you are x plus b over 2a square, you have this, right? Minus something equal 0. So this when actually this one be equal 0, the whole thing equal 0, you have the minimum. Okay? You have the minimum. So something like that. So when your curve move, your curve move up or down, your curve move up or down, you may have these, you may have these, you may have these. So when you touch it, you will have a double root. When you don't touch it, you will have no root. No root means that you don't have a real root. When you over it under the line, you will have two root, root 1 and root 2. Okay, that's what we are looking at right now here. Okay. So basically, this one you can use your determinant to determine your two root. So here we are trying to find a two root when we have a symbolic function of ABC. You should be able to find your root to be, your root is, I'm sorry, let me draw it again. This is not good. Let me use the right here. So you have two root. The line of symmetry is right here, and you actually do have a curve like this, right? So write this point, x equals minus b over 2a. That would be this part. This part is the line of symmetry, and then you plus minus this. So plus this minus this. So this portion of square root of b squared minus 4ac divided by 2a. That would be your what? Your this one would be your delta x over here. It's this portion is plus delta x. You got one root minus delta x. You find a second root right here. Okay. So when you have your square root b squared minus 4ac equals 0, that means you are touching the line here. You don't have the delta x. If this one actually b squared minus 4ac less than 0, you don't have a real solution for it. So you actually do not touch the line. Is that okay?
Yeah.
So when we are given a, b, c, a squared plus bx plus c, we should be able to find a symbolic solution. Symbolic solution means that we don't use a numerical solution. We use a symbolic solution. We should be able to find the data. So let's try this as symbolic part. So let's do symbolic dot py. Okay, so symbolic solution dot py. So here let's do this one called symbolic.py. Okay. Okay, that has an equation. That's this one. Let's call it parabola equals. Let's see. This one, let's call it 3, 2, 1. Okay, 3, 2, 1 is 3, 2, 1 is x squared a plus b plus c. Okay, this one is a, this one is b, this one is c. Okay, we reverse it because a is parabola 0, b is parabola 1. I'm sorry, a is a parabola 2, b is parabola 1, c is parabola 0. Okay, so that minimize it. We call it, just call it parabola p. Okay, so we get this one. Okay, and then we will do this. Okay, we will actually do define. Okay, this one actually find roots. Okay, and given a parabola pair P, okay, given the parabola P. So we are going to do A will be equals P2, B will be equals P1, C will be equals P0, okay, given a symbolic representation like that. So we find with our ABC, okay? And then we will actually get the so-called determinant. So delta, let's call it determinant. Okay, so determinant B squared minus 4 times A times C. Okay, this one is called determinant. Okay, determinant. So if the determinant actually is less than 0, okay, and then we will return none. None means like post root, no root. Okay, post root, no root. Okay, so we return 2 root, so we return a tuple. Okay. So now next one, if we have if determinant equals 0, then we have 1 root. So that 1 root would be equal to, let's do it, call it root, would be equal to minus B, okay, divided by 2 times A, right? And then we'll return the root will be root. That's the double root. Is that okay? Hello, is that okay?
Yeah.
Yeah.
And then we actually the rest of them, this is less than 0, equal 0, and greater than 0. The remaining is if determinant greater than 0, but we don't need it because these are cell cases. So we will have a root 1 equal to root. Okay, root is this minus B over 2A. Okay, so it would be actually plus what? Plus square root of the determinant. Okay, so right here, that's actually in whole mass. Okay, and then this one should be mass the square root of the determinant divided by 2 times A. Let me check. Okay, this is actually square root of the determinant divided by 2A, right? This portion plus some of this. That's correct. Okay. And then root number 2 would be this guy. Minus this. So by doing this, you see, we actually teach you how to find root and how to use the math library. Okay. And then this one right here, we are going to return a couple of R1 and R2. Okay. Okay. And then actually roots equal to find roots of the P polynomial, okay, P quadratic parabola. So if root 0 equals none, okay, then we say joint. There is no root, no real root. They are complex root, but no real root. Okay. Else, if roots 1 equals roots 2, we have double root of percentage f when 4f percentage root 0. I'm sorry, here I make a mistake. This one should be root 0 equals root 1. Okay, there's no root 2 actually. It's only two numbers. Okay, any questions so far?
No.
This one using percentage, this is use this one to replace this format. This is formatted print. Okay, if you can remember, we teach you the formatted print. We have that. Last one. Okay, last one is the last case. So here we will have else. Okay. We should have the roots of common percentage 0.4f. And then right here, you actually just, it's a double. So you actually put your roots should be fine because it will have two numbers. You'll be supporting this and this. It's a tuple. Okay, tuple good enough to put there. Okay. So right here, we are using 3 to 1. That will give you x squared plus 2x plus 3. Oh, that's wrong. This one should be should give you should be 2, 3, 1. Okay, 2, 2, 3, 1. 2, 3, 1 should be 2, 3, 1 should be x squared plus 3x plus 2 is actually x plus 2 times x plus 1. So you have a 1 root of minus 1, 1 root of minus 2. Okay, that actually is what we have. So that's actually to say, and that's wrong. Local variable root, and where is local variable root? Oh, okay, here root defined in the if statement, so that's not good. That's actually defined it first. And you will be used later, but it's okay. That's actually put a making sure it's not defined in here. Okay, this is not first time showing up here. So make it a global variable. Okay, sorry, that is something wrong. Okay, so basically we have a root of this, something wrong. Okay, something wrong. We have two root is wrong. Okay, let me check. Let me try. Okay, let me this one is called root 0, comma root 1, and then put them in parentheses. Let me try this one more time. Okay, make sure it actually go correctly. It's still wrong. Something wrong. Okay, let me see. Anything wrong here? We should get a -1 and -2. Okay, so right here, that's actually print this determinant. See if this one is correct or not. Okay, checking it. Wrong. The determinant is 1. Let me see. You have b squared minus 4ac. B is s squared plus 3x plus 2. So b squared is 9. 9 minus 4ac is 8. So this one, the whole thing equals 1. That's correct. Okay, so far this determinant is okay, 1. So that's 1. And then you have the root. Oh, this one is 0. Okay, so the root right here, I think my mistake is this root. That's actually should be copied and put it over here. Okay, put it over here. Okay, let me see if okay, a cannot be 0, so let's actually put it. A cannot be 0, so let's put it over here. Let's actually directly calculate the value here. Okay, so let's see this one like this. One more time. Okay, we got it. So that's correct. Okay, so calculate the root right away, and then you actually plus the distance to the right and minus the distance to the left. You find the two roots. Okay, so this one I think it's okay, not using this, just put the roots, should be fine. Okay. It should be able to print it out as well. Any questions so far?
No.
So this one is symbolic solution. Okay, you got a s squared plus bx plus c symbolic solution. Okay, now if you don't want to use a symbolic solution, you want to show it as a numerical solution. Numerical solution. Okay, numerical solution. Let's look at another one. Okay, let's try different one. Okay, let's try different first. Let's actually try copy. Okay, here let's call it P2. Okay, so P2, let's try 1, 2. Okay, so that would be a double root of 1. So here, let me change it to P2. Okay, so I'll change it to P2. P2, we run it one more time. So you will be double root of -1 is correct. Okay. So then let's try another one called P3, parabola 3. We do have the first one that I'm trying, 3, 2, and 1. Okay, and then we save it. And then we change it here, change it to P3. And then run it. There's no real root. Okay, so let's do that. And we can, and then now this print determinant. Okay, this one is a version. So you can change P1, P2 here to find different roots. Okay. So that's the first program for the symbolic solution. Now, second one, let's look at the so-called numerical solution. Numeric is not using the functions or symbols. Okay. So here we will be from pilot, import, start, import everything. Okay. Oh, we can also do import numpy as np. Okay. Okay, now we are going to do numerical solution. And we may also want to import mass. Okay. So right here, we are going to create a function. So we are going to have x. Okay. X equals numpy that linear space. Okay. And then this one, we know the solution should be at -2 and -1. So let's get started from -3 to 3. Okay, -3 to 3. Let's look at this range. Okay. So this one, your x is from -3 to 3. Okay, and this one you have 30 points, 30 points. So, and 0 in the middle is 0. So let's use totally of 61 points. Your x is this totally 61 points. Starting from 3 to -3. Okay, -3 to 3. Starting ending number and total number of the sample points, 61 points. This is linear function for saying that from -3 to 3, total is 61 point. Okay, linear space means that you create basically this is size 30 points, so it actually would be -3, -2.9, -2.8, something like that. Okay, something like that. Okay, anyway, that's your x. And your y should be equal to numpy. I'm sorry, y should be equal to. You should have a definition of the polynomial function of coefficients. Okay, give me the coefficient array. Okay, give me the coefficient array, and this coefficient array should be coefficient of 0, plus coefficient of 1 times x plus coefficient of 2 times x squared. And then you should also give me a x value. And I'm going to evaluate this polynomial function, okay? Given the x and this one, so we do have a sum equals 0.0. At the end, we are going to return this sum. Okay, we sum 0, and then we are going to do this. We are going to do for coefficient in coefficient. Every time we find a coefficient, okay, and then it will sum or plus equal the c, okay, and then sum time equals x. Let me see. Let me see. Okay, let me see. Something wrong. Okay, let me see. So your sum plus equals c, and then sum. Okay, let's cut this one. Put it right here. Okay, put this one first. So let's get started. So first one I have. We should come from the large number to the small number. Okay, sorry. So this one should be copied. I'm sorry. So this one should be coefficient of the -1 to the end using -1. The reverse, using reverse. So because you use the C2, then C1, then C0. Reverse order, okay. Reverse order, you get the, let's assume that you have a 1 to 1, okay. So you get this C2 first. So C2 times sum, you will have what actually times sum is 0, so you get 0, okay. So 0 plus coefficient is 1. So after the first round, you have 1, okay. You have a 1. The next one, you are going to time x adding to the sum. So this one you time x, you have the 1x here after the second round, okay. Then you actually times your plus your coefficient. Your coefficient, you will get 2. And then next one, you times an x plus 1. And then you get a result of this. This one is x squared plus 2x plus 1. Okay? Okay, anyway, this one should be your poly of the parabola, okay, and the t even is x for every t in x. Okay, so parabola p is equal to 1 to 1. Okay, let's use a 1 to 1. Okay, 1 to 1 is x squared plus x plus 1. Okay. So this poly will calculate the sum, actually evaluate. So it will be f of x equals x squared plus 2x plus 1. This whole poly function will evaluate that. So you for every t in x, so you find a point from your x, you put that value there, and then evaluate the polynomial function, and you get the value, and that value is y. Okay. After that, we are going to do figures, show, and we are going to do plot x versus y, red color. Okay. Okay, that's it. Let's actually save. And that's wrong. So you have this right here. Okay, it's actually double root. Is that okay? It's actually double root. Any question?
No.
And this plot we can make it prettier, but right now it's not our job. Okay, later I'll teach you how to make it prettier. So let me change it to the so-called 3 and 2. Let's actually change this one. Let's look at this root. Okay, double root case. So look at the double root case. Double root happen on -1 and -2. Okay, is that okay?
Yeah.
So this one is a numerical solution. Numerical solution means that your x represented on the number line of -3 to 3. Total is 61 points. So every 0.1 you jump by every 0.1, a sequence of that. Your y based on that, each of the t value, this is t value, to find f of t using the polynomial function here to find the f of t. So you got a plot like this. And then eventually you make a plot using the pilot to plot it. So this is how we actually calculate a mathematical function in Python. So here you learn sequence or list and comprehension list and function to evaluate the numbers and also making plot. Is that okay?
Yeah.
So compare these two. The first one only deal with the coefficient. They don't actually making the numerical. It don't go into the every single point to calculate. This kind of solution, we call it symbolic solution. Okay. And numerical solution is we don't care about the symbolic. We care about each individual value that we put into and see where are the points. So these two values usually is what when we do data science, we deal with numbers. We may find symbolic solution or find symbolic solution. Okay, a little bit more difficult than the textbook, and textbook just teach you the basic one. Okay, so here you do have the encode math and telling how to solve the roots. Okay, any questions so far?
No.
Aliena, are you okay?
Yeah,
Is that too hard or is that okay?
it's fine so far.
Fine so far. How about Sherry? Do you okay? Are you okay? It's okay if you feel it's too hard. Okay, I'll try to reduce the difficulty. Sherry, are you okay?
Yeah.
How about Belinda? Are you okay? Any
Yeah.
question? Any questions so far?
No, I don't think so.
Okay, anyway, they are math library you can use. They are also NumPy. NumPy is numerical Python. Numerical Python. Okay, that's what NumPy is. So this one we teach you a little bit of the library from NumPy because we import NumPy as NP. So this linear space is from NumPy. So NumPy also have the so-called local space. Okay, NumPy.log space. Okay, so NumPy has a linear space. Linear space means that you are 0.1, 0.2, 0.3, 0.4, right? Log space means you are 0, 1, 10, 100. Okay, this is log space. Okay, and you may also have actually NumPy log space. There's a log space. Let's try log. There's a log, okay, log function. Log function is your function is log char versus log char. Okay. When you do plotting, there's a log char. Anyway, that's too difficult right now. We don't go into there, okay? So what I say is that a lot of knowledge you learn from pre-calculus, after using the Python, you should be able to solve it using computer, okay? That's the whole purpose. So study hard in your pre-calculus or algebra 2 or calculus A, B, B, C, okay, and also AP stats, okay. Your college would success or value in data science and machine learning would depending on these different math courses. Is that okay?
Yeah.
And Python is under there to help you to do calculation with those different calculus, whatever courses you have. You really utilize the Python and you use these different maths to realize your machine learning and the data science. So data science and machine learning problem being solved by math being put onto the Python. That's how you integrate the programming and machine learning, data science, and math together. This is CS. This is AI. This is math. This is CS. Okay? Does that make sense?
Yeah.
I'm just trying to give you a very simple example, but here you should know about the power of these things. Okay. So far we teach you very simple math, and this library you can try. Okay. Next one is the factorial function. Factorial function is 5n. So Liana, what is 5n? Have you learned this before or no?
Yeah.
What's that?
I think it's like factorial. It's like
Is
for
what,
probability.
yeah, I know. In that class, yeah. But do you still remember what does the 5n defined? Is 5n been defined? I think you know it, but you forget it. It's okay. How about Belinda? What's the 5n?
I only know about the factorial one too.
It's 1 times 2 times 2, 3 times 4 times 5. So 0 band equals 1, 1 band equals 2, equals 1, 2 band equals 1 times 2 equals 2, 3 band equals 1 times 2 times 3 equals 6. 4 band equals 1 times 2 times 3 times 4 equals 24. 5 band equals 1 times 2 times 3 times 5 equals 120. Is that okay?
Yeah.
So here we want to calculate the n band. Okay, here we would like to calculate the n band. So n band, let's call it factorial C. I'm sorry. Should not be that C, should be the P1. Okay. I write too fast. I'm sorry. Should be the P1. Okay, let's define a function called factorial of n. Okay, given the n, we are going to calculate the n band. That will be 1 times 2 times 3 times 4 times 5. Okay. Okay, we are going to do this and this continue to times n. Okay. So to do that, we actually need to create a sequence of 1, 2, 3, 4, 5 to n. So we will do for each I in range of starting from 1 to n plus 1 because n are included. Is that okay?
Yeah.
So each I right now will be 1, 2, 3, up to n. Okay, we have this. We have the I equals this different number. Now we should have a something called product. Okay, so product start to be 1. Okay, and then you should have product and equals I at the end return what? Return product. Okay, so that's here. Let's do for x in range 1 to 6. Okay, and then point percentage d n equal to percentage d slash n percentage x and the factorial of so this one every time you have a new x, let's say starting from 1, 2, 3, 4, 5, and then you calculate the n band. So you have the n and the n band. So n declination minus n band equals the n band value. Okay. Okay, that's what we want to do, and that's actually safe and that's wrong. And we get these. Any question? And
No.
this look like this one change line. So we actually, if you don't want to change line, actually let's cancel the backslash n. Okay, you automatically change line, so you don't need the change line now. Okay, sure. So this one is to calculate the factorial. Any question?
No.
Liana, are you okay?
Yeah.
Do you remember this now or no?
Yeah.
Do you remember this n band now or no? Okay, it's used in probability. Yes, it's used in probability. Okay. Okay, that's actually the factorial that we covered so far. Okay, that's actually continue. Try to finish this chapter, okay? So that's the factorial stuff. We actually finished this calculation of factorial. Deep middle integer. Okay. Sometimes you want to calculate a big number. Okay, come back, you want to calculate a big number. And do a large number. Okay. Okay, but this one I think is okay. You will keep going until your machine break. Okay, that's it. So this chapter 3 is pretty simple to finish it already. Okay. But this one, because of this, we go through some math. It's okay. Okay, it's okay. We actually go through some math. That's okay. Let's go to the chapter 5. Okay. Let's go to chapter 5. Chapter 5 is on the file of the sequence string list and file. Okay. But before we go into file, we are going to talk about data science now. Okay, we're going to talk about data science now. And data science, we use a string list and file. So we will talk about data science first. Okay. Before we talk about data science, let's actually look at some slices that we used before for APCSP. Let's go to APCSP, okay? some of you finished that, but that's fine. Let's go to APCSP. So APCSP, let's get started with the information lecture 4. I think we cover this when we review the APSP, but this one is what I want to show, okay? Next one, you need to learn what's the data science. So the data science, you will have raw data, you process the data, and then you clean the data and use the data to build up your machine learning model to train it, and later provide a data product and make it visible on the website. So it's a whole life cycle for the data science, okay? That's the first thing you know. Now, in addition to that, we will start to look into table, okay? So table, we don't use this Python here. We are going to use some slices in web design. Right here, we have lecture. We go to the with Python. So we are going to use this one called I think this one. Okay, using Excel for an overview of data science. Okay. So this one you don't have a slice, so I'm going to attach it to the group to give you the slice. So this one is overview of data science using Excel. Okay. So we are going to study Excel right now. Okay. So let's look at Excel right now. Okay, let's get started. So we would like to learn charts, okay, with Excel. So you have Excel chart, type of different kind of chart. So today we are going to use the Excel to plot different kind of chart. And later we are going to save those files into Python and use Python to process it as well, okay? So first one, let's look at different chart. So Excel chart, chart provide the way of presenting your data in graphical format. That's called chart, okay? You have data and you present the data in the chart, we call it, okay? And there are different kind of chart. All chart are linked with data, okay? All chart are linked with data. So your chart type, you have bar chart, column chart, line chart, pie chart, SY scatter chart, histogram. Later we'll talk about these different kind of chart. Inside the chart, you have data label, data mark, data series, plot area, legend, and data point. Okay, these are different terminology when we talk about a chart. So there are different type of chart and the property in the chart. Okay, that you need to learn. Okay, so a chart is a graphical representation of data, and chart area is the data source. So we may have chart area wizard to create a chart. Okay. So this one we will use it this later. Let's try a different one. Okay, let's try a different one. Let me look at it. Okay, one moment. Let's actually do here. Let's do right here. Let's put development. Let's do look at Python development. Okay, right here. Let's look at chapter 8. So no such day. Okay, right here. Let's actually. Let me open this one. Okay. This one's a Python file. I may want to have Excel file. Let me see. JPEG, circle. data. Let me see. Okay, we do have a data file later. Let's check this Python file. Okay, there's a JSON file for it. I'm sorry. Let's look at the JSON file. The JSON file is right here. Let me see. Okay, let's use this data. Now let's go to Excel. Okay, let's go to Excel. Okay, let me create a new file. Okay, I create a new file. This new file, we would have two number that we are interested in. Okay, these two number we are interested is actually first one called year, second one called. Let me use a larger font. Okay, this in the font is too small. Let me use a 18. Okay, so there's a year. And then let me make this two column bigger. So let's use a column width of 20. Okay, so column 1 is year, column 2 called eligibility index. Let's call it EI. Okay. So what is this EI eligibility index? Okay, let's actually look at the San Jose State website. So San Jose State infection result. Okay. So what are these? Every year, a lot of students apply for San Jose State. Okay. And then let's look at the EI number. Okay, let's look at the computer science. So computer science student, the eligibility index will be 3440. This is called eligibility index. If you are above this score, you will get admitted. If you below this, you will be rejected. So this number is called eligibility index. Okay. So what is this eligibility index? Eligibility index is called eligibility index is your GPA times 800 plus SAT. Okay, and after the year 2000, we dropped SAT. So only GPA times 800 right now. Okay. But before, a long time ago, it actually was SAT. So the number roughly would be somewhere around 4,000 something. Okay. So SAT is 1,600, but GPA is somewhere around 3,300, something like that. Okay. So that's the number that you get, whether you got admitted or not. Okay. So right here, if you only have the GPA times 800, your admission is based on this number of 3440. Okay. But after the year 2000, we do not have the SAT. So I add the 1480 as the SAT score for comparison. But anyway, we got these two different numbers and we are going to put them into a table. Okay. So that's key in them. So we have the eligibility index EI. So 2012, starting from 2012, we have 4,000. 2013, we have 4,100. 2014, we have 450, 4,550. 2015, we have 4,300. 2016, we have 4,550. 2017, we have 4,500. Okay, up to here, we actually finish up to 2017. Okay, let's actually continue. 2018, we got 4725. You keep rising. Okay, 2019 is 4675. 2020, it actually is 4825. 2021, it actually 4880. 2022 is actually 4960. Let's continue. Okay, up to here. Okay, we don't need HYE here. We can get the data, but we don't need that. Okay, so this two is not aligned, so I'm going to change it to a line in the middle. So these two numbers look like this. So far, okay.
Yeah.
So this is actually one of these is called a column. This is called a row. Okay, another word to talk about it, this is also called a data series. And this is one category. Row is also called category. Column is also called data series. Okay. So any questions so far? So basically, data series is also an array. It's also an array. Okay, it's also an array. Okay, now anyway, let's select the whole thing. Select the whole thing. To insert. So insert here, you do have a chart wizard. So let's click the top left corner, bottom left corner, right corner, top and right corner. Click it, you bring up these things, and that's to select this column chart. So this one is a column chart. It shows you the score of every different year. Is that okay so far? This is making a chart. So this one is your year. This one is your eligibility index. It shows you where the number is. Is that okay? So this one called bar chart, vertical bar chart. You can also select the whole thing. Let's do it again, and then insert making chart. This time let's do this one. Okay, this one we call it linear chart. But it do have the dot to show you the data point. So it's also a scatter chart, the scatter linear chart. This one we call it linear chart. So linear charts tell us how fast the eligibility go up. Every year, the application is getting harder every year. Okay? Is that okay?
Yeah.
The trend. The trend of the data. Any questions so far?
No.
No? No, this one is to save. Okay, this one is save as, let's call it SJSU. Okay. Now let's actually save as this SJSU. Let's actually do, okay, let's actually isolate. Let's actually save as a copy. Let's go this. Let's go to this. Go to this. Go to Python that I have. Python data chapter 3. Chapter 3. No, let me change it. I don't want to call it chapter 3. I want to call it chapter 5 because it actually is in data processing part. So I'm going to save this on save file over there. Let me actually save as one more time, but this time I don't save a Excel file. Let me save as comma separately delimited file. Let's save this one. Okay, I save it now, and then let's actually change this one to chapter 5. Okay, look at this CSV file. It actually is year, comma, EI then 2012 for comma 4000. This. Okay. Now we got this one. Now we are going to process this data in Python. Okay. And that's our chapter 5's purpose. Chapter 5 is to handle file and the handle string and the list. Okay, let's do this. Okay, let's do this. Have some fun here. Okay. So we got a CSV file. We want to open the file and close the file and process it. Okay, so we got that file. So let me close it. This is not what we want. So right here, let's create a sjsu.python #1 file. Okay. So right here, we are going to do f equals open file. Open for file, it will open sjsu.csv file. CSV short for comma separated value file. Okay. So comma separate value file actually is, it also is a text file. It's the same as a text file, the same as your .txt file. But it actually comes with data of 2012, comma 4000, something like that. So two value, one is your year, one is your what? Your eligibility index. Okay. Now we got that. We are going to open the file and then read line by line. Okay, so we would do this. We'll do a line would be equal to f dot read line, read in a line. Okay, and while line, so line is not empty. While line is not empty, we do something. Let's do print the line. Okay. And then after that, we will do line equals f dot read line. So this whole thing is read and then while line and then print and then read line again. This one actually is reading the file line by line and print it every line, and at the end we do f dot close. We close the file. That's it. Let's work up to here. Don't do anything else. Okay, just open the file, read it line by line, and then print it line by line. That's it. That's all we do. So let's see, line 7. Oh, I'm missing a E. Okay, I'm missing an E. No problem. Let me put it back. Wrong it. See, so you read it line by line. Okay, but somehow each line is separated by a new line mark. That's wrong. Okay, that's wrong. That's wrong because your line has a change line mark there. We would like to clean it. So let's do this. Let's do line equals line dot strip. This one take out the new line mark /n. So your line remain the same, but the new line mark being take out. That's wrong. Okay, now it actually is line by line, line by line. Any questions so far?
No.
No question?
No.
No? Okay. How about Liana? Are you okay so far?
Yeah.
Reading every line and printing, reading every line and printing, okay? And I try not to go in too fast so you can understand it, okay? How about Sherry? Are you okay? Sherry, are you okay?
Yes.
How about Belinda? Are you okay?
Yeah.
Okay, now this one is version number 1. We are going to copy it to version number 2, okay? So copy it, that's actually paste. We are going to change the name say state.py to say state.py, say 2.py, I'm sorry. Sorry, hit the wrong key. Let's rename it. Change the name of say 2, okay? So here let me change the name. Eventually, or SJSU number 2.py. Now, reading like that doesn't make any sense. Okay, so here we are going to, okay, the first line is year, comma, eligibility index. So we are going to realign. Okay, and then after reading the line, we are going to do strip. No problem, we'll strip out right away. And then we are going to do this. We are going to do tokens equal line that's split. So you use this one, you actually use comma to separate them because your data is year, comma, eligibility, year, comma, eligibility. Okay, so we get that, and then we do this. We do actually year title. Let's do year title equal tokens 0. The token 0, there is a hidden space right there. We are going to take it out as well. So we do token 0 as strip. Now take out the extra empty spaces. Then we have eligibility title equals tokens 1. So we read a line and then take out those different just keep this portion, just keep the year and then this, okay? And we split this line into 2 parts, year and eligibility. So tokens would have 2 values. It's a list. Token is a list. Token 0 and token 1. Token 0 is the year, token 1 is the eligibility index. Okay, after that, this is a token, the strip, let's actually copy it. Still put it right here, okay? Because we are going to strip later, so here we don't need a strip, okay? So this one is continue to, so these are within the data lines, okay? Now we read in the data line, so we got a line. Right now we don't want to print it anymore. We don't want to print it anymore, so we got a line, we strip it, it's fine. We are going to split the token one more time. Okay, we split into the token one more time. Okay, we split into the token one more time, and we are going to do this. We are going to do, let's do this. Okay, let's do something called Y. Okay, Y is a year. Year is the converting into integer. What number converted into the tokens 0 plus 3. Converted into integer, that's your Y, okay? And then your eligibility index is using your tokens 1 plus 3. So you generate 2 numbers, okay? One number is Y, one number is E, okay? So right here, we are going to create a series of, this one is called rows. So let's call it, this one is called no. Let's create years equals empty list. And then let's create EIS, eligibility index equals empty list. Okay. Now we create that, and then we will do this. We will do years that append your Y into there. Eligibility S that append your E into there. Okay, you append the Y there and append the E there, and then we are going to do print your Y. This one is your years, and print your L dot J E dot G index. This one is your EIS. Okay, I'm sorry, EIS. So this one is your EIS. After you getting that from your table. So let's say, and let's run it. Got it? Any question?
No.
Any questions so far?
No.
No?
No.
So here we teach you how to read data from file line by line, and then actually each line we split it into two parts, token 0 and token 1. Token 0, we clean it by strip, taking out the leading and following spaces, and then convert it to integer y. And then token 1, we also strip it, convert it to actually the E, and y put it into years. E put it in eligibility. Okay. Now let's copy this one to another one. That's called San Jose State number 3. So San Jose State number 3, we are going to do something more. Here we are going to do from PyLab import and start. This whole thing, no change, no change, no change. Here just do figure. And then show. And then let's plot what? Years versus EIS blue. Using blue color to plot my years and also the eligibility index. That's it. That's it. I don't want to add too much other things. Wrong. Is that okay? Line chart being plotted. Okay, now one more thing. Right here, I'm going to do scatter chart. The same thing to scatter chart, EIS color equals field. Okay, field colors. This is scatter chart. Let's see what happened, okay? It added these different points right there. Field color. Now let me do this. If I take out this plot chart, just keep the scatter chart. Only the points. Okay, understand it now? So the plotting like this. Scatter chart give you the points here, whatever. Is that okay?
Yeah.
These are the purpose of the data processing in Python, okay? So first, we teach you how to read in data line by line, okay, line by line. And then we strip it, and then we actually doing that. And then later, we actually converted each line into two numbers, Y and E, and then append Y to ES, append E to EIS. And then last one, we actually making plots. Okay, we can do line chart plot. This one is called line chart. This one called scatter chart. Scatter chart give you the points, okay? Scatter chart points. So that's data science, data visualization, okay? And you learn this, you will be able to present your data, okay? And for someone who maybe like Belinda, maybe you go to summer camp to do biological study, you will need Python data processing, okay? That's the one that will help you to do research. Same thing for Vienna, if certain day you go to Cosmos or somewhere to do research, this one will help you, okay? Okay, these are different chart. Now, let's go back to files. Let's go back to files. So far we learned file line by line. Okay, let me go back to files. So let me go back to this one called SJSU, okay, number 0. Let me actually copy it and paste. Okay, this one, let me change it. Let me change it, call it declare the py. So no more, this one I'm going to do line by line reading, but I'm not going to read the so-called synopsis state now. I'm going to create a file that's called declare.txt. Okay. So what is declare.txt? I'm going to actually copy a file called declaration of independence text. So there's a national archive. Let's look at this one. Okay, that's what we want. Okay, let's actually just copy. So from in Congress, going down, let's go. Oh, that's too much. Up to here, up to honor. Okay, up to honor. And then right here, let's do paste. Okay, so here it is a file with the Declaration of Independence. Okay, now that's good. Let's actually save it. Now we go back to the declare. The py is the same as the synopsis state. It read in one line, print one line, read in one line, print one line. Okay, this one is that's called for this one. Declare one. Okay, declare one. Let's call it declare. Okay, so this declare the py is reading line by line and print line by line. Okay, let's do it. And you print out this line by line. Okay, print out this line by line. Now, sometimes you don't want to print line by line, so let's actually copy this declare and paste. May I read it in the declaration, but every time I read in the character chart. So this one, let's call it read in a character. So may I read in character by character? Yes, you can read in character by character. So to read in character by character here, let's call it ch. You do read what? Read one. While you have the character. Okay, this stripping of the line is no longer needed. Take it out. So you print the character. Okay, and here you read the next chapter of reading one. This chapter. So now let's actually add another one. Let's call it a counter. So here let's call it a counter equals 1. Okay, so that's a print the counter, comma, colon. Okay, here no. Let's actually do plus. Let's make them together. I don't want to have separated. same here. So let me print the character. Okay, and then every time the counter will increase by 1. And at the end, let's do print. Okay, there totally count. Okay, characters. Okay. Any questions so far?
No.
So you set your counter to be 1, and then you read one character. If there's a character, you actually print that character out. Then you read a new character, and then you increase your counter for a character. And then go back to check if the character is okay. And then you read in one more character and print it. And then you read another one and increase the counter, increase the counter in reading. Okay, that's what you will do. Now this one is reading the file character by character. So let's do it. This is in space Congress, whatever is character by character, character by character, keep going, keep going. Some of them are change line marks, some of them are space. It's okay. Eventually, this file has 8,180 characters. It's reading character by character. Is that okay?
Yeah.
That's character by character. Any questions so far?
No.
No? No, next one is actually copy, paste. So we do read one, that's read in a character by character. Now we are going to read in the file in a different way. This different way is that reading the whole file into one stream. So this one we still doing that, open the same file. You can do open for reading. Okay, here put that R is fine. So this one we will do actually reading the whole file. Okay, this one's declare of a whole. This time we are going to read in the whole file into one string. So we say the file string will be equal to f.read. Reader without number is reading the whole file into a single string. And then we print the file string. That's it. That's it. Putting the whole file into a single string, and we just print it using the print line. That's it. And that's run. You got this. Okay, you got this. The whole file was put into one single file. That's it. Is that okay?
Yeah.
Any questions so far? So we do read line that reading one line at a time. We do read one character. We do read the nothing that's actually reading into a whole string. Okay, next one, we have one more. This one, we are going to copy this declare the py, that's actually copy, and that's paste. For this one, we are going to change it. Let's call it list of lines. So declare underline list of lines. So we still open the file, still open it for reading, but here we are going to read it in lines. Okay, this is no longer common separate. I don't need to do. So we read in the file into lines. There are a lot of lines, so we do for loop for each line in lines. Print line and that equals empty. Let's don't use it. Line equals empty. Let's do this one plus 3. You take out the extra change line mark. So basically your data become what line 1, line, comma, line 2, comma, line 3, a list of lines. You read in the data into lines. These lines is a list of lines. And you print out each line one at a time. Let's put the line counter equals 1. And here let's put in str line counter. Put these. And before it, let's put a line that is this one. I mean, put them together. And then the line counter will increase by 1. Now let's save and let's run. It will be line 1, line 2, line 3, line 4, line 5, line 6, line 7. Keep doing line. That's how many line. And then here we will print. There are totally so many lines. Line counter being printed for so many lines. Before that, that's actually print the extra space line. Save as run. Okay, they are totally, oh, that's wrong. Actually, okay, wrong because I did not use the percentage mark. Percentage mark, use this one to replace it. Okay, so let me try one more time. Let's actually run it one more time again. Okay, we are totally 66 lines. Some of the lines are very long, but it's okay. So basically, you have a declare .txt. You can read in actually line by line. So using read line by line, you can read one character by character. You can read nothing, that's reading the whole file into a string. You can read lines, and then those lines are going into the different lines, a list of lines. So these are different ways to open and read the data into your processing area. Okay, so you need to practice this different way of reading file in. Is that okay? You put a smaller file by yourself and then try to write a program to read the text file into your program one by one. Okay, you should do that practice, and also try to rewrite the stage program by yourself once. You should be able to learn what we teach today, creating the file and read in the file to process it, and then making plots. So these are basic data processing, okay? And today we teach you what is file and teach you basic processing of the files. And next time we are going to go for more complicated chart. Is that okay?
Yeah.
Okay, after here today, and then this week, you at least need to finish the chapter 3 homework if you like. Chapter 5 up to you, okay? If you want to finish chapter 5, you can try. If you don't want to finish chapter 5, so homework is okay. Chapter 4 will come later, so skip the chapter 4, okay? So 3 must, 5 optional, 4 later, okay? Any question?
No.
Besides that, I also need you to rewrite this different file, open a file and read it in, open a file and reading by reading in line by line, reading in the single character, reading in the whole file into a string, reading in the whole file into number, a list of lines, and using different way to do it. Okay, that's the very basic file processing that you need. Okay, if you cannot handle this, you pretty much cannot follow to do data processing in Python. Okay. Okay, that's it for today. Good night and bye bye.
Night.
Thank
Bye-bye.
you.